I'm just going to read from the top as it reads up on your sheet. It says the first 10 lessons in Module 4 have focused on expressions. Expressions are given so that we may evaluate them, find the answer whenever possible. Now we're going to turn our attention to equations. So I'm going to ask you, what does the following equation mean in your own words? Put it into words. You have a 4, you have an equal sign, you have a 4. Okay, I'm going to say they're both equal to each other. Okay? Notice we have a quantity on the left of the equal sign and a quantity on the right. Those two quantities are equal when that equal sign says that they're equal. Yes or no? What is the sign that we use when things are not equal? Do you have somebody come up and actually do it, maybe? Nick, come on up. Just watch out for the line here. Yeah, you put a line right through it. Have you ever seen that? Okay, if something's not equal, you put a line through it like that. That means the two quantities are not equal. All right? All right, so what we said here is that this is indicating the quantity or value, if you will. Says, get out loud, the quantity or value on the left is equal to the quantity on the right. The metaphor that I like to use is I want you to think of an equation as like a scale. You know what a scale is with the two pans on one on the left, one on the right. I don't mean necessarily the scale where you get on one thing and it's like a balance scale. I think you've done it in science, right? The difference being you got to move over it's a triple beam, you got to move over the weights. You know the scale where you got the two strings attached to the pans, and if you put an unknown weight on one side, the scales tip, and then you got to balance it out by putting another. You know what I'm talking about? Yeah. Okay. Think of an equation like a scale. Our goal is to find what value would be put on one side to balance out the quantity given on the other side, as you'll see when we get into algebra. Okay? Think of it like a scale. This term, underline it. Who remembers what standard form is? Joe. That's expanded. I think you're thinking. Standard, just the opposite. As short and as simple as possible is standard form. So, if I give you this expression, I'll write this down. Right now, that's technically an expanded form. How do you write it or rewrite it in standard form? Which is? Right. Okay, that's kind of the way it works. So now, if you go to the next page, I think it's your next page. No, it's the bottom. Go back to the previous page. What we do is anything that's not in standard form, we put it in standard form. So 6 plus 3, we look first to the left of the equal sign. What's 6 plus 3 in standard form? Write your 9. Bring down your equal sign. And is 9 already on the right side in standard form? Just bring it down. And are the two quantities equal? As simple as that looks, for now, go with it. Do the same thing for B and C. I'll call you up to the front. With B and C, you got to put both in standard form and then evaluate it. Yeah, come on up to B. Just watch out for string here. Or choose any color. went with blue. Don't let it ruin your day. Jordan, come on up and choose any color you want.
Alright.
St. Patrick's Day thing.
Yeah.
Okay. And that's good. So you've learned the simple as well. Good job. All right, let's take it a step further and model out what we're doing here. Okay, so we have a balanced equation here, 4 equivalent to 4. All right, we're going to use, remember tape diagrams from back in ratios? We're going to revisit it a little bit, not that much, just a little bit so you can see it. Each piece of tape segment is going to represent 1 unit. Good, Jordan. Yep. So make 4 boxes, each one is worth 1. And that's going to equal 4 boxes on the right, each have a value of 1. I kind of had the luxury of erasing through a smartboard, so I'm going to remove 1 box. But then I'm going to rewrite it, because you guys, I don't want you guys erasing. But if I remove 1 box from one side, are those 2 expressions equal? All right, now you're going to have to rewrite it. And what you can do to signify that you're taking 1 out, just put a line through it. Change my mind. I do want you to erase that first box if you can. Now, if you have N, just put a line through it. Okay, because I don't want that crossed out box to kind of confuse you. I want you to see you have 3 on one side and 4 on the other. Now, I want you to put a star next to number 3 because as simple as this seems, it becomes a fundamental principle of understanding algebraic equations. Right now, you have 3 boxes on the left, you have 4 boxes on the right. What do I have to do in order to, once again, make both quantities equal? I can do 2 things. What's one of them, Matt? I can remove 1 from the right. Okay, now they're not both going to be equal to 4, but they would be equivalent, would they not? What would they be? 3 equals 3. What else can I do? I could do that, but if I take half from here, that's 2 steps. I got to remove half from one side and then add another half to the other side, don't I? I could do that, though. Okay, that's kind of, no pun intended, out of the box thinking. I could add 1 more to this side. Okay, but that idea of being able to remove and add quantities on either side of that equal sign is really a fundamental principle of understanding algebraic equations. It's going to build on that, but just think of that idea of always saying to yourself, what must I do to one side in order to make this equal? All right? So let's just summarize that. Going back to the original tape diagram, what if I add 6 boxes to the left? What would I have to do on the right side to balance it out? Mia. If I take 6 brand new boxes and I add them, and I don't want you to do this, but I'll show it to you. Right now, is it balanced or not? Mia, what would I have to do on the other side to balance it out? I'd have to add 6 brand new boxes to this side to balance it out. That's 6, that's 6. Make it circles quickly. So that's kind of like another idea that you just learned and you don't even think it's a big idea, but it is that whatever you do on one side of a balanced equation, if you want to keep things balanced, you got to do the same exact thing on the other side as well. That's also a fundamental principle of algebraic equations. If you take away 1 on one side, what would you have to do on the other side? If I take away a box on the left, I got to do 1 on the right. Take away a box on the right. Okay, if I add 3 to the left, what do I got to do to the right? Okay, keep that in mind too, because we're going to revisit that. So I just summarized that idea that you have to add 6 boxes to the other side. And like I said, I just told you these concepts, even though they sound simple, they're big ideas that you got to always revisit. And those big ideas again are whatever you do on one side of the equation, you got to do the same thing on the other side to balance it out. All right, let's go. Now you come to your first legitimate algebraic equation. And that's x plus 1 on the left and 9 on the right. Now, I know you can do it in your head. I know it. But I want to show you the method in which they're going to expect you to solve these when you get up to 7th and 8th grade. It's going to seem real simple. But as you'll see, these equations will get more and more difficult. And you've got to have the method down. All right, first of all, let's do it in reverse. Just let's do what you already know. And then I'll show you kind of the method that they want you to solve these. What value? Right now you have an unknown value for x plus a known value. This is called a constant. I know I've used this word before, but I want to kind of revisit that as well. We have a variable plus a constant of 1 on the left that equals the quantity on the right. Well, let's just do it. What is x equal to? Right now, it's not balanced unless I give x a value. What value do I have to assign it in order for it to be balanced? Agreed. How do you know? Jay, how do you know? Okay, so what you did is guess and check. You substitute a value in, which we've been doing, and you add the digits up, a plus 1. You kind of put that in standard form, and you wind up getting 9 equaling 9, and that's how he did it. Okay, so that's just simply called guess and check or mental substitution. Yeah.
So I did 1 minus 9, and I got it.
And that, what he just said, we're going to get to.
Famous.
Okay? Jordan said is he took away 1 from the left and then took away 1 from the right and got the value for x, which really is the fundamental principles of understanding how to solve algebraic equations. Good job. But for now, Jake's way is good too, because we're going to actually always check our algebraic equations that way. You're going to substitute the value. I call it mental substitution because you did it in your head. And then you evaluate each side. This part 3 I kind of already did up top, but I'll show it again here. We substituted 8 in. Now you kind of right back to that example 1, where you're going to put each side in standard form. That becomes 9 in standard form, and obviously the right side is already in standard form, and it checks. This is what you kind of want to get to. You want quantities to be identical, left to right. Okay? You do that by simplifying whatever junk is on the left. If you could simplify it, put it in standard form, and then do the same thing on the right. And if those two quantities are identical, you have a balanced equation. All right, now we're going to kind of go back and revisit how Jordan did it. Model it out with T. I want to get this done before the bell rings. You have an unknown quantity for this box X. We're not done. Plus a quantity that we do know, which is 1. That's going to equal 9 boxes, each equaling 1, which if you think about it, I took the 9 that was on the right and I put it in expanded form. Okay, that's what that 9 is 1 plus 1 plus 1 plus 1 plus 1 and 9 of these. I technically, what I did is put it in expanded form. Make sure you have 9. And that's where I'm going to stop for today. Actually, I'm going to see a period 3, right? I know, they're supposed to ring. Let me stop this. Alright, picking up where we left off, period 1. We got as far as realizing that if we take this expression x plus 1, and we remove that block from the left side, what do you have to do to the right side in order to balance it out again? Okay, you have to remove a block from the right, as we did when we did our 4 equals 4 and I made one side heavier than the other. We realized that if we take away a block from the left, we're going to take a block away from the right to get balanced again. So if I do that, and I'm able to erase, but I will show it to you. You can put like a dotted line through it and show it to your block from each side. What's the only thing now left on the left side? An unknown x, followed by an equal sign, and then count up the boxes now on the right side. Tell me what you get at. The boxes are on the right. What do you notice? What do you notice? Okay. Right. By doing what we did, otherwise known as the Jordanian Method, Jordanian Method, is that instead of just putting in that 8 or substituting that 8 in for x and doing 8 plus 1 in my head to make 9, and we go back to this. Okay. The way he did it, and by the way, Dylan Baca said the same exact thing, that I could subtract that plus 1 on the right, do the same thing on the opposite side, and get my solution for what x is equal to. And that kind of will become the method in which we're going to solve all algebraic equations. It's called inverse operation to solve equations, as you'll say. So we wind up by getting x all by itself. It's called isolating the variable. We can figure out what that value for x is. So I'm just going to write it out. I'll read it out loud to you while you're copying it down. The remaining, if I spell remaining wrong, the remaining value on the right, 8 in this case, is the solution for x. What we just did, like I said, is we used inverse operation to solve for x. So if I show you again that original equation that we had, this x plus 1 equals 9, what are we doing to the variable known as x? Focus. What are we doing to x in the original equation up here? What's being done to it? Sam, I'm adding 1 to it. So in order to get x by itself, and that's what your goal is going to be in every one of these equations, your goal, your finish line, your purpose is to try to get the variable, whatever variable it is, all by itself. We do that by using inverse operation. So if I am adding 1 to x, you've got to do the opposite. All right, let's practice this idea of inverse operation. I want you to go to example A on the next page. If we can follow the steps that are outlined here, we don't have to model everything out. So it's always going to be the same exact question I'm going to ask you every single time. I'm going to ask you, what side is the variable on? What's being done to it? What do we have to do to undo it or do the inverse? So take a look at x minus 5 equals 13. So the first thing I'll ask you, because a variable could be on either side. What side is the variable on, left or right? Shout it out.
Left.
Write it out.
5.
Now here comes the important question. What are we doing to x? What operation is being done to it, and by how much? And we are taking whatever this value, this unknown value is, and what it's eventually going to be, we're subtracting 5 from it. Work that out. Inverse means opposite. What's the opposite or inverse of subtracting 5? No. Adding 5. What you have to remember is if I'm going to add 5 to the left side, going back to that first principle back in first period, whatever I do on one side, what do I have to do on the other side? Got to do the same exact thing to keep it balanced. So if I'm going to add 5 to my left side, I have to add 5 to the right. That's the steps in words. I'm going to show you how to show it on your work page from here on out. You start off by writing the original equation. X minus 5 equals 13. I could model this all out, but I'm not going to. So if you understand the idea of do whatever the opposite of whatever's being done to x, do the opposite. The opposite, subtract 5, is you show it by adding 5 underneath it. Now what I also like my kids to do, and they'll do this in 7th and 8th grade also because I've seen it. These are called train tracks. And a lot of times I will call this method the train track method. Because all you're doing is you're making 2 rails that follow down because you want to keep both sides of the equation separate. And you make these little equal signs and they look like train tracks. It's done. Alright, so I've taken away my 5 from my left side. What do I have to do on my right side to keep it balanced? I have to add 5 plus 5. Okay, now here comes like a little small leap, but tell me if you're okay with this. If I have 5 of something, or I'm subtracting 5, and then I add 5, what is my resulting value? In other words, negative 5 plus 5 equals what? 0, right? Nothing, right? You agree? Are you okay with putting a line through it because we say it cancels out? They no longer exist. I don't have to worry about my constant anymore. Are you okay with understanding that? You want that constant to cancel out because your goal is to get x all by itself. Do you have x all by itself? Bring it down. So that's the only thing that's left on that side. Where did I lose you? We're crossing it out because if I have negative 5, I do the opposite. Okay? If I'm at negative 5 on a number line, and I take 5 steps to the right, where do you wind up? Like 0, right? So it cancels out. It leaves nothing. Okay? Just the way that I showed that these two quantities, the result of it is 0. But I don't want to do x plus 0, because x plus 0 is x. So it cancels out. I'm just showing the x. 13 and 5 don't cancel out, though. 13 plus 5 is what? 18. That winds up being your solution.
That's the answer.
How did I do it? By using inverse operation. Now, we still have to prove it. I know you know it's correct, but we still have to show the proof or the check. And here's how you do it. You write the original equation is why we did so much substitution the last couple of weeks, especially yesterday. It's because you got to get substitution in your head. What value are we claiming x is equal to? 18. Substitution in. Sure. Focus. We want to put 18 minus 5 in standard form. We don't want to leave it like that. I know you know 18 minus 5 equals 13, but the goal in the check is you've got to have your most simplest and your most simplest on both sides. So you actually evaluate 18 take away 5. What does it make? And once those two quantities, those two numbers in standard form are the same, you now know for sure that the answer or solution to x minus 5 equals 13. The answer for x is 18. If you follow the steps every single time, it doesn't get any more complicated than that as far as how to solve it. The equations themselves will get more advanced, but the method is always the same. Let's go to example B, see what they call it. B. All right, now we've got 64 equals 8x. Don't forget your basics. This means 8 times an unknown value is 8 times an unknown value is 64. We have to find the unknown value. Take it step by step. First of all, what side is the variable on?
Right.
It's on the right side this time.
Yeah.
Don't let it throw you off. It's still the same principles. What operation is being done to the variable? So, by how much? Nick? By how much? You got it. We're multiplying by 8. Agreed? Addition and subtraction are inverse operations. What's the inverse of multiplication? Right. Division. And if we're multiplying by 8, we've got to divide by, correct. If I'm going to divide by 8 on the right side, what do I have to do on the left side to keep it balanced? So, correct. Now you have everything in words. I'll show you how you show it. What do I write first? Let's see if you can do this. Raise your hand. What do I do first? What's our first thing? Put up. 10. 10. Alright. So we write the original equation first. Now remember back in lesson 9, I showed division. Which was lesson 10 actually. Jake, you remember? Right. No more little division signs. It's too many symbols. That means divide by. How much, Jake? You got it. Stand my train tracks. So now here comes my lead question. On the right side, what can I put a line through? In other words, what cancels out? A lot of hands, good. Dylan. My 8 and my 8. Say goodbye to the 8s. Did I achieve my goal? Do I have x all by itself on one side? I absolutely do. Goal accomplished. Now you just got to do 64 divided by 8. 8. But now we got to prove it. Yeah, what do I write first here in the chat? always. Now, what am I substituting in for x? You got it, but now watch what happens, everybody. I have to add those parentheses or use a dot. Well, I like parentheses because I want you to see it and get used to it. So that means 8 times 8. What you can't do is put two 8s together because what's the easy 8? Now, our left side is already in standard form, but we've got to standardize our right side. What's 8 times 8? The elusive 8 times tables. They're snipers here.
I love snipers.
Press up now. 64. It checks. Circle it because we proved our solution. Our solution. Now, guys, understand too, because I've had kids do this. When they write on their answer sheet what the answer to this solution is, they'll put 64 because that's the last thing that they did in the chat. The answer is not 64. We're solving or trying to find the value for x, and that's done back over here. Our answer is 8. That's what you write on your answer sheet. That's if it's multiple choice. That's our answer. This just proves it. All right, one more example, and then you guys could be able to try algebra on your own.
It was like x.
Talk to me. Go ahead.
So let's say.
Is this the example?
Uh-huh.
All right, go ahead.
So let's say it's x times like 6 or whatever, and I'll put.
Right now you have minus though. Times.
Yeah.
Okay. X minus 6. Okay.
If you add this to that, that gives you x. If you add 6 to 27,
Which is exactly what you're doing though. The reason why, yeah, you're right. So you're adding 6 to both sides. Exactly. But you're doing the inverse operation to do that. All right, example C, and then I can have you guys work in groups, all right? Take a lookie. Same thing as always, which side has the variable? Left side is correct. If you want to put L or R, you can.
I wrote LEF.
Trick question, what operation is being done to the variable? So you can remember.
Division.
NOS. Correct. Remember that bar now means division. By how much, Nick? Divided by 7, right? Griff, what's the opposite of divide by 7? You got it. Tell me, what do I have to do the other side? What do I have to do the other side if I'm going to multiply one side by 7? Correct. Now we just got to show it. It's all written out. Original equation first. Okay, so write it out. Why is it why?
Really good book slide too.
How do you want to show multiplication? There's two options that I'll accept. What I won't accept is an X symbol. So what do you want to do? What do you want to do? You could do parentheses if you want. The only thing that is I do ask is that when you build these, you build it from the top down. So I don't want you to put anything in the same line as your y over 7 or y divided by 7 equals 10. I'd like you to write it underneath. And I will accept parentheses or a dot's fine too. No more X's for multiplication. Okay? I like parentheses because dots sometimes get in the way as decimals. And it's possible you can have a decimal in an equation. If you're okay with that, the parentheses 7 meaning multiply, and you're comfortable with it, that's what I would use. Extend my train tracks. What was this?
I like turtle.
What cancels on the left side? Yep. want that constant to cancel. We want a variable by itself. That's always our goal. Nick, leaves us what on the left side? Don't forget, this is multiplied by 7. Looks like our variable is equal to 70, but we've got to prove it. Write the original equation. Meg, what am I substituting in for y? What are we claiming that y is equal to? Substitute that in. Where you see a y, I'm now going to put the 7. Okay, so now we got to evaluate the left side because it's not in standard form. Tris, what's 70 divided by 7? It checks out, doesn't it? That proves our answer that y is equal to 7. Try a page all by yourself. I can have you group up, but I want to check everybody. So I have to make sure that you are doing the steps exactly the way that I'm showing you. Yeah. Time out! Before you begin, you'll notice when you get to the exercises, to make it a little bit lighten your load, eyes up here. We're not breaking it down where I'm asking you verbally which side has the variable, what. All you're going to do is go right to it. Say to yourself which side has the variable. Which is what? Left. What are you doing to the variable? So you're going to do the opposite, which is? So you've got to show the actual work steps without having to write it out verbally like you did in the examples. That I will allow you to, skip. But the work has to be shown the same way. Get Aiden.